Hey there, pre-cal students. We are doing today lesson 110, analyzing piecewise functions. So we're looking at piecewise functions in the context of real-world problems, how that works. Piecewise functions is something that really lends itself very easily to real-world examples. So hopefully you'll find this interesting, a little bit more applicable than some of the more theoretical things we do. So here it comes. Okay, this is lesson 110, analyzing piecewise functions. So let's jump in here. Mary has a standard routine each morning. She leaves her house and walks slowly at a constant rate for 4 blocks to the Starbucks, which takes her 20 minutes. She then sits and drinks her Mocha Grand Cafe Latte Supreme for 10 minutes. Then she walks briskly at a constant rate the remaining 6 blocks to school with the help of the caffeine. It only takes her 10 minutes. Draw a graph showing her distance from home in blocks as a function of time. Alright, so let's look at how far she's going and how much time it's taking her total. And that will give us some idea of how we want to scale these axes here. So I can see here that we've got 20 minutes plus 10 minutes, that's 30, plus another 10 is 40. So I want 40 minutes here on my x-axis. So if I go by fives, I have 5, 10, 15, 20, 25, 30, 35, 40. That's going to work out pretty well. So let's do that. So we're going to put time in minutes, and each line will represent 5 minutes. So we'll have 5, 10, 15, 20. Okay. Now she is going 4 blocks, and then she sits for a while, and then she goes 6 more blocks. So I need 10 blocks going up here. And so I think I've got plenty of room to do 1 line per block. Really, I've got 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, I can. So we'll say distance from home. And the unit is blocks. All right. So at time 0, she's at home. 0 blocks from home. She leaves her house, walks slowly at a constant rate. So this is going to be linear. Constant rate is going to be linear. 4 blocks to Starbucks, which takes her 20 minutes. So in 20 minutes, she'll have gone 1, 2, 3, 4 blocks. Okay. So there we go. All right. She then sits and drinks her Mocha Grande Cafe Latte Supreme for 10 minutes. So she sits here for 10 minutes, does not move any further away from her house. Then she walks briskly at a constant rate the remaining 6 blocks for another 10 minutes. So 1, 2, 3, 4, 5, 6, 5, 10 minutes. So I'm going to get something to draw this with. And there we go. So that should represent Mary and how far away she is from her home. All right? So, questions about this now. Number 1, what is the rate of change? When we're talking about rate of change, we're talking about slope. So what is the rate of change at 5 minutes? Normally, we could move up and say rise over run. But the problem with this is that our scale is different on these two axes. We're going by 5s on the x-axis. We're going by 1s on the y-axis. So at 5 minutes, we want to find the slope of this line, but it's going 1 block per 5 minutes, right? So that's how fast she's going at 5 minutes. At that point right there, she's going 1 block every 5 minutes. So 1 block in 5 minutes, 2 blocks after 10 minutes, 3 blocks after 15, etc. So her rate of change is 1 block in 5 minutes, which we can just say is 1/5 of a block per minute. All right. At 25 minutes, she's sitting at the Starbucks, and she has 0. The slope of that is 0. There's no rise at all. So 0 blocks per minute. for 25 minutes. And then at 35 minutes over here, she's now going, I can count up 3 blocks every 5 minutes. So 3 blocks in 5 minutes is 3/5 of a block per minute. So she's going 3 times as fast as she was going before she got to Starbucks. What is her distance at 10 minutes? After 10 minutes, she is 2 blocks from home. We can see that from the graph right here, 10 minutes, 2 blocks. And write a function for the graph. All right, so what we have is a piecewise function, right? So I've got 3 pieces. I've got line segment, line segment, line segment. So f of x equals, we know that the slope here is 1/5 a block per minute. My y-intercept is 0, so I'm simply going to say 1/5 x. Actually, let's use t for time here. 1/5 t, and we'll say that is from 0 until 20 minutes. 0 less than or equal to t less than or equal to 20 minutes. At that point, it just changes to, it's going to be 4 for a while, right? So 4, and that's going to be from 20 minutes. Notice I'm going to say less than, since I put less than or equal to 20 minutes up here, I'm going to say strictly less than here. 20 is less than t up to 30 minutes. Less than or equal to 30 minutes. All right, this last one, I know the slope over here is 3/5. So it's going to be 3/5 t, but this one, the y-intercept's not going to be 0, and we need to figure out what the y-intercept is. So I'm going to use y equals mx plus b. And I'm going to say, let's use this point right here. This point would be 30, 4. So 4 is my y, equals 3/5 times 30 plus b. Do a little cross canceling. 5 goes into 36 times. And so 4 is equal to 18 plus b. If I subtract 18, my b is negative 14. So 3/5 t minus 14, and that is for 30 less than t, and that's going to go until she gets to school, which is going to be at time 40. So there's our piecewise function. All right, let's go to the back. So consider each of the following situations and write a transformation of f of t. Okay, so look at these. We've got we got 5 different things here, 5 different situations, and it's going to be changes to f of t. So look at those, think about it, jot some things down, see what you got. We'll come back. I'm going to pause the video, and we will come back and we will check answers in just a sec. Okay, so let's go through this. Mary wakes up, begins a routine 15 minutes earlier than usual. 15 minutes earlier than usual. So that's going to shift everything 15 minutes to the left earlier. And so that's going to, in terms of my function here, I'm going to say f of t plus 15. It's shifting left, which you would think is going to be minus. So we do the opposite, plus 15. It's changing our time. All right. Number 5, school is starting later than usual, so she enjoys a leisurely morning where she allows herself twice as much time for each part of her journey. Okay. So we have twice as much time. Again, this is changing our x-axis, our t-axis in this case. And it's going to twice as much time. We do the opposite inside the parentheses. And so this is f of 1/2 t, which will give her twice as much time. 6 says she woke up 5 minutes late but maintained her usual pace, so she's starting 5 minutes later than normal. So this is going to be t minus 5. We'll shift things 5 to the right. 7 says, shift up a little bit here. 7 says she has to get to school early for a faculty meeting, and so she got up at her usual time, but has to do everything in half the time. So this time we have compression instead of a stretch. Up on number 5 we had a stretch. Now we have compression, and it's half the time, and so we're going to do the opposite, which would be 2 times t. And number 8 says she woke up 30 minutes late, and so is starting her journey later and has to do everything in half the time. All right, so my first function, she wakes up 30 minutes late. So that would, right off the bat, that's going to be t minus 30. And then she does it in half the time after that. So I'm going to say 2 times t minus 30 here. Okay? The 2 here, opposite, 30 minutes late, it's going to shift things 30 minutes to the right, so we put minus 30. And then the 2 here, since it's half the time, multiplied by 2. We do the opposite again. Okay? All right. Last page here. Sorry, got another page here. There we go. Last page. It says match each story to one of the graphs A through E, where D represents the distance from home and T is time in hours since the start of the bike ride. Graphs may be used more than once. And so we've got 5 situations here, and then we have 5 graphs, but it is possible that one or more of the graphs may be used more than once. It's possible we will not use all the graphs. Okay? So read this over. Got 5 here. All right. Here's your graphs. And I'm going to put these into I'm going to let you see if you can match the ones that go together, and you can check yourself on Edpuzzle. Okay? All right, that is it for this lesson. All right, I hope that made sense to you. You have some practice to work on. Please upload it when you're done. And I hope you don't have any, I hope it goes well for you. All right, so let me know if you have questions, and we'll talk to you tomorrow. Bye-bye.